Okay, if we talk about some basic concepts of friction, because you know about the direction that friction will always act in the opposite direction of motion. It is a type of resistive or opposite force that always act in the opposite direction of the direction of motion, right? Or we can say that it is a force that opposes one space moving or to move over and right. Just on a slippery or very shiny surface, we used to wear a rubber slipper, so that will give us a maximum friction. Let's suppose if we slide a tile over another tile, that tile is made up of marble. So you know that marble tile is a very shiny and is very slippery. So it will easily overlap or it will easily pass over the other surface, though there will be very less friction or negligible friction, right? And let's suppose if you want to drag one rubber tile over another rubber tile, so you know that rubber is a rough type surface and there will be a maximum friction in between rubber surface. So this is the concept of friction. We already experienced different examples in our daily life, and that will help you to understand the concept of friction in our daily life, right? So I hope that there will be no confusion in the basic concept of friction, right? We usually walks on the ground surface, so we usually wear shoes or slippers like this that are easily to walk or easily to drag over the surface. So sometimes if there is a water on the floor or water on the ground, so then there are three layers now. One layer is of ground, second layer is of water, then we place our foot on that surface. So due to that water layer or due to that liquid layer, there will be a less friction as compared to the original friction between ground and the sole of the shoes, right? So this is the concept. And there are some important terms related to friction, like there is a concept of static, and concept of sliding friction or dynamic friction, we can say that. So what is the basic concept or what is the basic definition for static friction? Let's suppose if we consider example of an object. Let's suppose if object is placed on a surface like this. Let's suppose if we want to apply a force towards right hand side like this, and we consider our applied force with a symbol of okay. So what will be the direction of friction? Friction
Negative P?
direction, yes. So this will be the
Negative,
direction
like
of
the weather.
friction,
Yeah.
yes, negative direction. And let's suppose we consider F for the friction because our main focus is on friction. So F is the symbol for friction and P is the symbol for applied force or the direction in which body is going to be moved, right? Let's suppose if we increase the value of P, right? And so what will happen that box will eventually starts to move from its rest state. Okay. So
Okay.
and if we apply just a very little force, that block is not moving. So we can say that body is in equilibrium state, right? Because friction and the applied force both are equal and opposite to each other. So that is one concept. And what is the other concept? Other concept is, let's suppose if we apply a slightly little force, and force will be like this, that your P is greater than F, slightly greater than F. So in that condition, we can say that friction has its maximum value, right? Because we are applying just a little force as compared to the friction. So when body is not moving, let's suppose when body is at rest state, so at rest state, you know, both forces are equal, right? But let's suppose if we just increase a little force as
Oh,
compared,
wait, no, sir. When it's at rest, aren't both forces equal to zero
we can say that their
if it's at
resultant,
rest?
yes, their sum will be equal to zero, or F equals to P
But
means both are
if it's at
equal and
equilibrium,
opposite. Yes. So actually, rest means I
if
am
it's
talking about
equilibrium,
the,
then it'll be equal to each other.
yes. So I, we are
Oh,
talking
okay.
about the, it's not talking forces. So sometime we use the rest word, sometime we use equilibrium, but concept is right that we need to use the equilibrium concept. So if both forces are equal and opposite, so body is at rest state. And let's suppose if we apply this condition that P is slightly greater than F, so you know that we just pass out the maximum value of friction, right? Because if we don't overcome the value of the friction, so block is not able to move in the direction of P. It will remain in the same position just like the equilibrium state. Okay. So in static friction, we can say that if the value P is the applied force in our case is increased, the block to move. So it means that when a block just starts to move from its equilibrium state, so it gives you the concept that F has its maximum value, right? F max
Sir, when the value of
plus,
F will be equal to P with the object, can we say will it ever move at constant speed or will it always stop?
we can say that if we write the word zero over here, rest means that body is not moving. But it is also possible that when body is moving with a constant speed, so at constant speed, all forces are again balanced. So that is the second type of friction. After static, we are going to discuss that example. Okay.
Okay, okay.
So friction has its maximum value, and this maximum value, or at this stage, the friction is known as the static friction, right? Because this is the point where we just overcome, or we just overlap this value of the friction. So that value of friction is known as, that maximum value of friction is known as static friction, right? Because we just overcome the value of friction and we start to move from equilibrium state. And the next concept that you mentioned about the constant speed, so that concept is related to the dynamic friction, because the word itself is,
Yeah, the value can be anything other than zero, one, two, three, four, like that.
yes. So if we talk about the dynamic friction, we can say that when the block is moving with constant speed, block is moving with constant speed, object is with constant speed, so what will happen?
So can you
So,
repeat? Your voice cut out.
okay, wait.
You were asking something.
Yes, I was asking about when the block is moving with constant speed. So, what will be your observation then? If block is moving with constant speed. So initially we talk about the static friction, that we slightly increase the value of P, and in that condition or in that specific state, the friction is known as static friction. But let's suppose when block is moving with constant speed. So continuously we are moving constant speed, but there is one concept, and what is that? Because in forces we discussed that when all forces are equal and opposite, so body may move in the form of constant speed, right? Because when body is moving with constant speed, so all forces are equal and in opposite direction, right? But if you
Yeah.
think about it, that body is still moving. So moving means that body is moving in the direction of P. Okay.
Mm-hmm.
So it means that your value of friction is slightly less as compared to the static friction, right? Because now body is moving in forward direction. So with respect to direction, definitely it means that your P is greater than the value of F, right? We know that
Yeah.
we are moving with constant speed, so all forces are equal and opposite, but it's still the if we consider the direction, so direction tells you that body is moving towards right hand side, and this gives you the concept that the friction is slightly less as compared to the value of static friction, right? So
Yeah.
we complete this statement like this: when the body is moving with constant speed, so the value is slightly less, not very large difference between initial friction and final. So the value is slightly less. So this is the concept of them. So these are the concept that will help you sometime if they ask in MCQs, if or if they just ask about you to write a statement or briefly explain what is the static and dynamic. So that will help you to explain the concept, right? Any confusion?
No, sir.
So basically in second situation, your P is greater than F. Yes. So P is equal or than F because we are moving with constant speed. So slightly we are greater than the F. But almost we are in equal and opposite condition of forces, right? But due to direction, we consider that P is greater than F. So that's why we use equal and greater sign in second situation, right? Okay, so friction is not much very detailed in our section because you observe mostly they ask about direction only in exam papers. So that is not a big deal. The most important concept in this chapter is related to driving and car safety. So the concept of car safety is about the terms that are included or that are in your section of braking system. So let's suppose usually when we are driving a car or when we are riding a bike or bicycle on a road, so when we saw some speed breaker at some distance, so we actually in our mind we just plan all the thing that when we are going to push that brake pedal and how long car will take to slow down and we can easily pass over that speed breaker, right? This is a natural process because in our daily life we don't think or we don't make a scientific or mathematical calculation, because by experience we got the things that when we need to push that brake pedal and when to release the brake pedal and how to decrease or how to increase the speed with respect to any speed breaker or any hindrance in the path on which we are moving, right? But
Yeah.
if we think about scientifically, or if we use some scientific terms on this specific experiment, so there are basically three terms related to distance. One is known as the braking distance, second is known as the thinking distance, and the third one is known as stopping distance, right?
So
So
what's the thinking distance?
yes, so that is important. Because most of questions in worksheet you found that all are talking about the braking, thinking, and stopping distance. So let's suppose if we first talk about the braking distance, or first of all we start with thinking distance, because this is the first. And now we is this thinking. Actually, it since let's suppose if we start from some specific point, moving from this specific point this direction, and there is a speed breaker over here. Whoever riding a bike or bicycle, so he or she knows that when to slightly push that brake pedal before we reaches the speed breaker, right? So when you are thinking about it before applying the brake, your foot is not on your brake pedal. So all the time or all the distance that you covered before applying or before your reaction time. So that distance covered during that reaction time is known as your thinking distance, right? Let's suppose your foot is away from your braking distance, right? You are slightly moving closer to the speed breaker, right? So now what you are thinking, that you need to push that brake pedal to decrease your speed, right?
Yeah.
So let's suppose this is the point where we start thinking about this process. Okay. Normally it not happens like that, but it's still when we are driving for first or second or third time, so it happens, right? We are continuously thinking that when to apply brake, when to increase the speed.
Yeah.
So that is the important thing. So let's suppose at this specific point, we start thinking about to apply the brake, right? We are not actually apply the brake. We are just thinking about, because we know that we take some reaction time and then our foot actually presses the brake pedal and body will start braking from initial point to the speed breaker, right? So let's suppose we cover some distance during this reaction time, because when we are thinking, so car is still moving. So it covers some distance. So let's suppose this is the distance covered during our thinking process, and this distance is known as the thinking distance, right? So if we want to write
Okay.
the definition, or if you want to just explain this term briefly, so you can simply explain it as the thinking distance is the distance traveled during reaction time driver is known as thinking distance, or in short, reaction means before brakes applied. It is just before we start to apply the brake. Means that when your foot starts to touch that brake pedal, so before that contact between those foot and those pedal, so before that contact, the whole distance we covered is known as the thinking distance, right? So before brakes apply.
Yeah.
And your second concept is related to the brakes, because when we are about to brake, so the next process that we starts to apply brake, right? You need to apply force
So when you're
brake pedal.
drawing and you say something, your mic just cuts out. Can you check
Okay,
that?
okay,
Yeah.
okay. Let's suppose if we talk about the braking distance, right? So braking distance is when we think about it, and this is the point where we actually thinks that we need to apply brake, and after this green dot we just press that brake pedal, and you know that whenever we apply brake, so it will take time to stop the vehicle. It is not like when we press the brake pedal, so suddenly the vehicle stops, right? It will not happen like this. If
It
whatever
takes 2 to 3 seconds.
it takes 2 to 3 seconds, and during that 2 to 3 seconds, there is also a distance covered by that body, right? And let's suppose if we
Yeah.
suddenly applies brake, so still car will slide or drag or slip on the road, and it will again cover some distance during that the time interval, right? So braking distance is simply a distance covered by a body or distance over which brakes applied before vehicle brought to rest, right? So actually this is the distance between this green point and the point where actually car stops, right? So this is your braking distance. And for definition, we can just simply write it as this brakes applied for vehicle brought to rest, right? So this is the distance when we just press down that brake pedal, and before coming to rest, the total distance covered in that short time interval when car is just skidding or sliding that surface. So that distance is known as the braking distance. And what is your final term actually relates with? Your final term is related with the stopping distance.
Sir, is it important that in the braking distance the car has to come to rest? Because when the speed breaker is there, the car doesn't exactly come to rest. It just slows down, and after
Yes.
the speed breaker, it just speeds up again. So is it
Yes.
important for it to come to rest or just slow
Uh,
down?
no, it is not important to rest because we actually take a specific condition to
It
explain.
comes really close to rest.
Yes, the minimum speed that you reach before passing over that braking speed breaker. So you consider that one as the final state of your car, right? The minimum speed
Yeah.
that you want to reach. Because in rest state, we actually want to stop our car. But when speed breaker is in front of us, so we actually need to decrease our speed. So the minimum speed that you want to reach, so that is will be like our rest state or will be like our braking distance, right?
You slow down the car just to go smoothly over the speed breaker. You don't completely stop.
Yes.
Yeah,
So
thank
that is
you.
the concept. So the minimum point when you reach just before the speed breaker, so that is your braking distance. And then you just pass over that speed breaker and you again increase your speed and moving with that constant or variable speed. So actually we use the concept of the rest state because that was very easy to understand, right? And stopping distance,
Yeah.
very simple. Now we know that we just start thinking from this specific point and we still cover distance till the speed breaker or before speed breaker. So this whole distance is now equal to the stopping distance, right? Because the thinking process, the braking distance, both will combine and gives you the concept of stopping distance. So stopping distance is nothing, it is just a total distance during thinking and braking distance, right? So we can simply say that total distance traveled, the time it takes to stop a vehicle, right? Or in very simple equation, we can say that it is the distance, stopping distance is equals to the thinking plus braking distance, right? So this is a very simple definition of stopping distance, that is stopping distance is the sum of total distance plus the braking distance, okay?
Sir, when it asks us to write the definition in the exam, can we
Mm.
say the stopping distance is the total of the
Yes.
thinking distance and the braking distance?
Yes, you may also write in the
Okay.
manner that that is the total distance covered by a body during thinking and braking, or it is the addition of the total distance plus the braking distance, right?
Okay.
Okay. In your past paper, they also asked about one important thing that is related to the factor affecting thinking distance, right? So let's suppose if they ask you about the factors that affects your thinking distance. So we are going to talk about the factor and what are the factors. First, we talk about the fact that affect your thinking distance. Priya? That what are the
Yes,
factors
sir.
that actually affects your thinking distance. So let's suppose if we consider a driver driving a car and we have to just figure out what are the factors that is important for thinking distance, right? And one more thing that we observe from the definition, that thinking distance actually depends upon the reaction of the driver, right? That how fast or how slow driver will react, right? So actually it depends upon, let's suppose if driver is driving for last 4 or 6 hours, right? So one thing is it depends upon the level of tiredness of the driver, right? Because we need to write very journal
Fatigue,
factors.
fatigue.
Yes. So we are not going to write very scientific factors over here. We are going to write very journal factors. So the first one is,
If he's paying attention to the road, if he's tired, if his brakes are even working properly.
yes. So
Could it
all
also
these,
be the experience of the driver himself? Because like some just start driving, some have been driving for like a decade. So like the experience in
yes.
driving.
Okay.
Yeah.
So it depends upon the driving experience also. So driver's degree of tiredness.
And then driver's attention.
Yes, and driver's attention or experience all are in the same point. We need to write
Ah,
like the eyesight and the visibility of that driver, right?
yeah, yeah.
Would the type of the car matter? Because different type, because if it's a big car, then it has to brake
Mm,
like
mm.
more before the speed breaker than a smaller car, right?
Okay.
No,
Actually,
but that's the braking distance. That's for the
yeah.
braking distance.
So that the tire conditions are actually for braking distance, right? We saw different ads of different cars tires. So actually they gives you the concept to just quickly stop your vehicle in a very short interval of time. So your point is actually related with braking distance, right? Because that is the distance during which our vehicle is coming to rest. So before that, all distance covered during the braking application. So your tire condition, road conditions are actually the factors of braking distance, right?
Oh,
Actually,
right.
thinking is completely depends upon the driver, right? Because it is a thinking process. So only driver can think. So all factors are actually related to your driver. And one more thing, let's suppose if someone is sick and having some medicines or there may be some drug or
Yeah,
alcohol.
mental issues, mental issues,
Yes. So because
mental
it is,
issues.
yes, so it's actually added up in your syllabus or in your exam specification. So that's why we need to write use of alcohol or drugs. So that is also important point,
Oh, yeah,
instance, right?
yeah.
So these are enough for your thinking distance because mostly they ask about one or two or just they compare to write 1 point for thinking, 1 point for braking. So the second thing you mentioned for the condition or the physical state of the car. So those are the factors of braking distance.
The type of tire, the type of road,
Yes.
the size and mass of the car.
So it depends upon the condition of the road, quality of a tire, condition of a tire. It's up to you.
Would it depend on the traffic?
It depends upon.
The traffic or not?
No, it not depends. Actually, if let's suppose if you saw some other vehicle, just suddenly comes in front of you. So actually, our purpose is to just stop before hitting that car, right? So again, our purpose is same. So our thinking distance will quickly change, our braking distance will quickly change. So actually, it does not depends upon the traffic or the other, because that affect again the thinking distance, right? So it depends upon your reaction time, that how quickly you react, right?
Oh, okay.
So condition of road, quality of tires, because it will depends upon that. Let's suppose if there is a rainy season and there is a wet road, so you know that we always just place our foot on the braking distance, sorry, braking paddle, because we know if we apply suddenly brake on a wet road, so car will skid or slide. So that's why we just slowly push down that braking paddle, right?
Yeah.
And one more important thing, let's suppose if you remember, we talk about inertia. So in inertia, we discussed that mass actually increases the value of inertia, right? So it means that, let's suppose if your car or is your vehicle is heavily loaded, right? So you know that because of inertia, it will also take time to just coming into the state of rest, right? So it also depends upon the load carried by your vehicle.
Like the amount of passengers.
Yes, let's suppose we saw that sometime our car is overloaded. We just fill up all the things in our backside of the car. Let's suppose we are going to over some trip or with some friends. So more than enough persons are seated in our car. So that will also increase the inertia of the body, because we discuss in inertia topic that mass actually depends upon, or inertia actually depends upon mass. So if we increase the value of mass, inertia will automatically increase. So car is moving in forward direction. So to stop that car, we need to also take care of the load carried by our vehicle. So that is more important also, right? Let's suppose if we take the example of a motorbike when we are traveling alone. So we know that there is no one place behind us. So we apply brake according to that. But when someone is sitting behind us on a motorbike, so then mass will increase and we will apply brake more quickly as compared to the initial condition, right?
So if
Yes,
the mass
sir.
increase, so the braking distance will also increase.
Yes. So actually stopping distance is depending upon distance and braking distance actually depends upon your thinking, right? Let's suppose if you suddenly apply brake, so your braking distance will be short, right? Because you take a greater time period to think about it and to apply brake. Okay. So it also depends upon like that when we solve questions related to this topic in our next class. So then we will also discuss that how we use these concepts, right?
Okay.